We recently explored how the combination of liquid stone and metal skeletons changed the very shape of our cities. We saw how this new hybrid material offered the strength of a mountain and the flexibility of a tree, allowing us to build taller and wider than ever before. But there was a massive hurdle that almost stopped the concrete revolution before it truly began, because for a long time, nobody knew if they could actually trust it. This was not just a technical problem, but a psychological one. The world had built in a certain way for millennia, and asking people to abandon the weight of history for a slurry of wet mud and iron bars was a monumental request that required more than just math to solve. Imagine standing on a construction site in the middle of the 19th century. You are an architect who spent your entire life learning the predictable behavior of oak beams and granite blocks. For thousands of years, the rules of the world were simple and heavy. If you wanted to build something that lasted, you stacked heavy things on top of other heavy things. You understood the weight of a stone because you could see it, feel it, and witness how it sat in the earth. Stone was honest. Wood was familiar. You knew exactly how much a pine header could hold before it began to groan, and you knew that a block of marble would not simply dissolve in the rain. Then, a salesman arrives with a bag of gray powder and a handful of iron rods. He tells you that if you mix this dust with water and hide the metal inside the sludge, you can create a floor that is thinner, lighter, and stronger than anything made of solid rock. It sounds like a miracle. But to a professional responsible for the lives of thousands of people, it sounded like a disaster waiting to happen. To the builders of that era, concrete felt like a magic trick. It was a liquid that turned into a solid, a material that had no visible grain and no clear history. It was an invitation to gamble with the very ground people walked on. The problem in these early years was not just a lack of technology, but a total lack of certainty. This was the era of the Wild West in construction. Because the chemistry of Portland cement was still relatively new, every manufacturer had a different recipe. One batch might set as hard as a diamond, while the next batch from a different factory might crumble into sand after the first winter frost. There were no universal rules for how much water to use, how long to let the mixture dry, or even how deep to bury the metal supports inside the walls. Every builder had their own secret method, often protected by confusing patents that they guarded like crown jewels. If you hired one contractor, he might tell you the iron should be at the bottom of the beam. Another might insist it belonged in the middle. If a building collapsed, the inventor would blame the water or the weather, but never the fundamental uncertainty of the material itself. This created a massive bottleneck for the industrial world. Cities were growing at a frantic pace, and the old ways of building with wood and brick were becoming a liability. Wood burned too easily, turning entire neighborhoods into ash in a single night. Brick was sturdy, but slow and expensive for the massive factories and warehouses required by the new economy. The world was desperate for a material that was fireproof and cheap, yet the very material that promised to solve these problems was viewed with deep suspicion. If you were a city official or an insurance agent, how could you approve a building made of a material that had no history? You could look at a Roman arch and know it would stand for centuries because the proof was right there in front of you. You could see the ancient mortars still holding firm. But a reinforced concrete warehouse was a giant experiment, and nobody wanted to be the one standing under it if the experiment failed. The banks were hesitant to lend money for structures that might not outlast their mortgages. The insurance companies were terrified of the liability. The gray sludge was a dreamer's material, but it was not yet a banker's material. The turning point did not happen with a single invention, but with a change in how we measured the world. To make concrete work on a global scale, it had to stop being a secret art and start being a boring, predictable science. This required a brutal process of trial and error that played out in laboratories and on testing grounds across Europe and America. engineers began to realize that they could not rely on the promises of salesmen or the anecdotes of inventors. They needed to see exactly when and why a concrete beam would snap. They needed to strip away the mystery and replace it with data. Picture a testing facility in the late 1800s. It is a place of incredible violence and noise. Massive hydraulic presses, the size of small houses, are used to slowly crush blocks of concrete. Scientists watch with notebooks in hand, recording the exact moment a crack appears and the precise second the entire structure gives way to the pressure. They are looking for the breaking point. They load hundreds of tons of pig iron onto experimental floors to see how much they sag, measuring the tiny fractions of an inch that the material bows under the weight. They build small concrete huts and fill them with wood and kerosene, lighting them on fire to see if the material can actually survive the heat of a real urban inferno. They would watch as the flames licked the ceilings, waiting to see if the concrete would explode from the internal steam or if the metal skeletons would soften and fail. Through this destruction, a new language was born. It was the language of standards. Instead of having 100 different ways to mix concrete, committees of engineers began to write down the rules. They defined exactly what Portland cement should look like, how fine the powder should be, and what chemical properties it must have. This sounds like a dry administrative task, but it was the equivalent of building the tracks for the first railroads. It created the foundation for trust. Once everyone agreed on the standards, the fear began to evaporate. If a builder used certified cement and followed the standardized formulas for reinforcement, the insurance companies would finally sign the papers. The banks would finally lend the money. The gray sludge was no longer a mystery. It was a commodity. It became something you could order from a catalog with the confidence that it would perform exactly like the last batch. As these standards took hold, the scale of construction exploded. The economics of the material were simply too good to ignore. Unlike stone, which required highly skilled masons who spent years perfecting their craft and commanded high wages, concrete could be poured by almost anyone. You needed a few expert engineers to design the structure and oversee the mix, but the heavy lifting could be done by a massive workforce of relatively unskilled laborers. This democratized the act of building. You could now create a massive bridge or a 10-story factory using local sand and gravel combined with a few shipments of standardized cement and steel rods. The elite craftsmanship of the past was being replaced by the industrial efficiency of the present. This shift changed who won and who lost in the urban landscape. The traditional guilds of stonecutters saw their power diminish as the demand for their slow, expensive work dried up. Their ancient knowledge of grain and chisel was suddenly less valuable than the ability to manage a concrete mixer. In their place rose a new class of professional contractors and structural engineers. These were people who lived by the slide rule and the data table. They were not artists in the traditional sense. They were managers of a complex chemical process. The buildings they created reflected this new reality. They were often stark, functional, and massive. They were monuments to the new science of reliability. The era of the skyscraper was no longer a dream of architects. It was a reality of the balance sheet. The ripple effects of this standardized concrete moved far beyond the city limits. It enabled the creation of the modern water system with massive dams and miles of underground pipes that brought clean water to millions. It allowed for the construction of massive silos that could hold the grain of entire regions, stabilizing food prices and changing the global economy. Every time you drive over a highway overpass or walk through a parking garage, you are standing on the results of that 19th century fight for standards. We stopped guessing and started calculating. We stopped fearing the unknown properties of the mud and started relying on the physics of the mix. Today, we live in a world that is essentially draped in a skin of reinforced concrete. It is the most used man-made material on the planet, second only to water.
It is the literal foundation of our civilization. But the very standards that allowed us to build the modern world are now facing a new kind of pressure. We are discovering that the marriage between the concrete and the metal inside it is not a permanent one. Over decades, water and salt can seep through the microscopic pores of the concrete, reaching the iron or steel skeletons. When that metal rusts, it expands with incredible force, cracking the concrete from the inside out. It is a slow-motion explosion that is currently threatening bridges and buildings all over the globe. The material we once thought was eternal is showing its mortality.
Furthermore, we are grappling with the fact that making the billions of tons of cement we need every year is one of the biggest contributors to carbon emissions. The intense heat required to transform limestone into cement releases vast amounts of gas into the atmosphere. The very industry that was born out of a need for safety and reliability is now part of a global environmental challenge. We are back in a period of intense experimentation, looking for new recipes and new standards that can provide the same strength without the same cost to the planet. We are looking for ways to make our liquid stone even smarter, perhaps even capable of healing its own cracks or absorbing pollution from the air. We are searching for the next generation of trust, trying to find a way to build for the future that does not compromise the world we already have. The story of how we paved the world is not just a story of chemistry, but a story of how humanity learned to trust a new idea. It took decades of arguments, thousands of broken test beams, and a total overhaul of the legal and insurance systems to move from a bag of dust to a global infrastructure. We proved that we could manufacture the very ground we walk on, provided we all agreed on the rules of how to do it. We transformed a suspect sludge into the bones of our cities through the sheer force of measurement and observation. While this dance between concrete and its metal skeleton redefined our cities, it was missing one final ingredient to truly reach for the clouds. To understand how we moved from sturdy factories to the soaring heights of the modern skyline, we have to look at the metal itself. We need to take a quick step sideways in our story to see how a different breakthrough made the reinforcement inside the concrete cheap and plentiful. In the next episode, we will look at Bessemer steelmaking and the arrival of cheap steel, which served as the missing context that turned a clever building technique into a global revolution. If you enjoyed this look into the foundations of our world, subscribe for more history behind the tech you use every day.